This problem is a little bit of a long problem once again, and this time, unlike the last two problems we did, the variables aren't necessarily given in the order in which we should find them, meaning that my list on the left-hand side where it says find RT, IT, VT, that's not necessarily the order we want to approach this problem. So the first thing we're going to do is look at what we have given. So I have R1 equals 4 ohms, R2 equals 12 ohms, R3 equals 6 ohms, and I3 equals 2 amps. And if I look at this circuit, overall, the big part of this circuit is that it's a parallel circuit. So R1 and 2 are in series together, but they're in parallel to R3. So I'm going to think about this as a parallel circuit overall, but I want to try to get R1 and 2 data together. So to start, I'm going to say, since R1 and R2 are in series, I can use my series rules about resistance and find the total resistance of R1, 2. To do that, I just add the resistance of R1 plus the resistance of R2. Now I can say resistor R1, R2, or R1, 2 equals 4 ohms plus 12 ohms. So R1, 2 equals 16 ohms. So even if you want, you can write that right up into your diagram if that helps you. So I can say that this is 16 ohms. So now I can move on to finding my total resistance. And like I said, if we think of R1, 2 together, we could say that it's in parallel with R3. So now I can switch to my parallel rules and find my total resistance. Now my total resistance if I'm looking at it in parallel, remember that to find it, I actually have to do 1 over my total resistance. Those are my parallel rules. Equals 1 over R1, 2 plus 1 over R3. Now I can say 1 over R total equals 1 over 16 plus 1 over 6. I can combine my fractions by finding a common denominator. I'm not showing all this right here for that. But if you did, you'd end up getting 11 over 48. And then I have to do the inverse of each fraction and solve for my answer. And I would end up finding that R total equals the inverse of 11 over 48 is 48 over 11, or 4.36 ohms. And I'm going to put that piece of information up here in my given so that I know that I found that. Then I'm going to look at my circuit, and I see that I already have R3 and I3, so it should be pretty easy to find V3 just by using Ohm's law. So I can say V3 equals I3 times R3. So V3 equals 2 amps times 6 ohms, V3 equals 12 volts. So I'm also going to add this to my givens up top. After that, since I'm still thinking about this really as a parallel circuit, with R12 being in parallel with R3, I can say that according to my parallel rules, my total voltage is equal to the voltage at resistor 3, which would be equal to the voltage at resistor 1, 2. So my total voltage is equal to voltage 3, which I just solved for, which is 12 volts. And I could also add that to my givens at the top. And just as a little note to myself for later, I'm also going to write over here that it equals V12, just so I don't forget. Now, if I look at my list of givens, I have my total resistance and my total voltage. So the next logical thing to find would be my total amplitude, my total current. So let's pick another color so we don't get anything mixed up here. I'll go back to green, and I can say, with Ohm's law, that V total equals I total times R total. And since I'm looking for I could say that my total voltage divided by my total resistance equals my total current. So I have 12 volts divided by 4.36. And that ends up being 2.75 amps. So now I want to go back up to the top, and I'm going to add that piece of information to my givens again. And that just helps me keep everything straight as I move forward. So now that I found my total current, I can use that with my parallel rules to look at resistor 3 with resistor 1 and 2 together as R12. And I can say that according to my parallel rules, my total current equals the current in resistor 1, 2 plus the current in resistor 3. So my total current, my 2.75, well, let's manipulate that first just so that we can get I12 by itself. So I can say I total minus I3, which was one of my original givens, equals I12. So I total my 2.75 amps minus I3, which is 2 amps, equals I12. And I have 0.75 amps equals I12. Now I can use that and apply that idea to my series rules. And in my series rules, and I'm using series rules because resistor 1 and resistor 2 are in series, so I can say that the current in 1, 2, or the total current is equal to the current in resistor 1, which is equal to the current in resistor 2, where that 0.75 amps is the current in resistor 1 and also the current in resistor 2. So I can also add that information to my list of givens. And for the last step of this problem, we have to find voltage 1 and voltage 2, or voltage at resistor 1 and voltage at resistor 2. So it's pretty easy now because we have both our current and our resistance for those. So we can go right back to Ohm's law. And I can say that V1 equals I1 times R1. So V1 equals 0.75 times R1, which is 4 ohms. So the voltage at resistor 1 is 3 volts. And I could do the same thing to solve for my voltage at resistor 2. So V2 equals I2 times R2. So V2 equals 0.75 times 12. So the voltage at resistor 2 equals 9 volts. So now I can do one last check of this problem. Think back to this piece of information we wrote down before. So if I want to check my work, I can say, okay, well, overall, this was a parallel circuit again. So in my parallel circuit, I had said before that the total voltage would be equal to the voltage in resistor 3, which would equal the voltage in resistor 1, 2. Another way to say this is that the total voltage is equal to the voltage in resistor 3, which is equal to the voltage in resistor 1 plus voltage in resistor 2. And I can add those together because resistor 1 and 2 were in series. So now I can say 12 volts is equal to 12 volts equals 3 volts plus 9 volts. So 12 volts equals 12 volts equals 12 volts. And that's just a good check to finish off this problem.